Hello friends, today's question, figure A, object D is placed on object A which is stationary on the frictionless horizontal plane. Object B and C are compressed together by a spring and placed on top of A. When the spring is released, B and C separate and begin moving at constant speed in opposite directions. In figure B, object C collides with the object D and they combine to form a single mass, moving together at constant velocity v. Subsequently, object B collides with A and they combine into another single mass which also moves with constant velocity. It is given the mass of the object A is 5m, B is 2m, C is m and D is also m. And the question is asked which of the following explanation is correct based on the given scenario. And it is given some conditions given that objects move within the same vertical plane, the mass of the spring is negligible, and top surface of A is frictionless and parallel to the horizontal plane. The statement, there are three statements which you have to find out which of them is correct. Statement A, in figure A, immediately after B and C are separated by the spring, the magnitude of their momenta is equal. In figure A, the speed of B is v immediately after B and C are separated by the spring. And in figure B, the speed of A and B after they collide and combine is given as 2v by 5. So we have two figures. This is figure A and this is a figure B. So initially B and C are, you can say, connected with spring and they are released. B and C moves in opposite direction. C combines with D as shown in figure B, and B combines with A, where A is the, you can say, bigger block which acts as base for everybody. So we have to find out the first part, prove that rather, whether it's correct or not, that immediately the momenta of both B and C is conserved, equal rather. So this entire question is based on the conservation of momentum. So we start from there only. So we say that when spring is compressed, the system is at rest. When spring is compressed, the system, so here system is B and C. B and C are at rest. So it means we can say momentum of B and C will be equal to 0. So we can say momentum of B plus C will be equal to 0 because their velocity of B plus C is equal to 0. And when they are released, we say velocity of B is given as Vb and velocity of C is given as Vc. We can assume it. Okay. So we say when spring is released, velocity of B is taken as Vb and for C it is taken as Vc. Therefore, the momentum of B will be equal to its mass is given as 2m multiplied by Vb, and momentum of C, its mass is given as m multiplied by Vc. So their total momentum after, you can say, releasing total momentum after spring release, let us call that as P, B plus C, total momentum P total will be equal to momentum of B plus momentum of C, and this gives us twice mVb plus mVc. Now, according to conservation of momentum, initial momentum will be equal to final momentum will be equal to final momentum. Initial we know is 0, so this will be 0 and will be equal to 2m Vb plus m Vc, and from here we can say that our Vb will be equal to minus Vc by 2. This we simply calculated the relationship between the two, or in terms of momentum we can say the momentum of B is given as Pb and momentum of C is given as Pc is equal to 0, and their magnitude wise we can say Pb momentum is equal to the Pc momentum. So from here we can say the momentum is what was asked, the momenta are equal, the magnitude of momenta are equal. That we can say magnitude of momenta are equal. So first part is true. Okay. So we can, this statement is our true statement. So we can say statement A is true. Statement A is true. Now we come to statement B. And it's given after separation the velocity of C and D will collide and they will be moving with a velocity v. Okay, because it is given they combine and move with the velocity of v. Okay, they move with the velocity of v. So we can say that after separation C and D collide and move together with velocity v. So here also we are going to use conservation momentum. Initial momentum will be equal to final momentum, and we just said that the velocity of C is our Vc. We said the velocity of C is our Vc. Therefore, momentum of C, we can say initial momentum will be equal to momentum of C plus momentum of d, and these are initial momentum. D is at rest, so this becomes 0, and we can write for this c, the mass is given as m, so this becomes m multiplied by Vc, and our final momentum both are moving together, so final momentum of c plus d will be equal to mass of c, mass of d, and they are moving with same velocity v. So now conservation momentum. Conservation of momentum, initial is equal to final momentum. So we can say our initial momentum is equal to final momentum. We substitute the values, we get this is m multiplied by Vc is equal to 2m multiplied by V, and here m and m cancels out, so we get that our Vc is equal to 2 times V. And we are supposed to find out here the speed of B immediately after, you can say, are separated by the spring is given as V, and we know relationship between yeah, here it is, the relationship between VB and VC. So we can say, but our VB is equal to minus of Vc divided by 2. We substitute it here, we get minus of 2 divided by 2, and this comes as minus of V. So magnitude, we can say, therefore speed of B will be equal to VB, and that will be equal to our V. And negative sign only indicate that in opposite direction. So we can just put it here. Negative sign indicates B moves in opposite direction. That's all. So statement B is also our true. So statement B is also our true. And we are left with last statement now. So we can say statement B is true. B is true. And for the last part, so when A and B collide, they also move together. So when A and B collide, they move together. With the velocity of suppose VAB. Once again, conservation momentum. conservation of momentum. Initial momentum is equal to final momentum. Initial momentum is equal to final momentum, and initial momentum means momentum of A plus momentum of B is equal to momentum of A plus B, because they are moving together, and A is stationary. Therefore momentum of B is our 2m Vb, and A and B move together, so this is 5m plus 2m, and we have this as VAB. Now it is simple calculation. This get as 2m Vb is equal to 7m VAB, and m cancels out. So from here we get twice Vb is equal to 7 times VAB, and our VB we just calculated is our minus of V. So we substitute here, we can say but VB is equal to minus of V. So therefore we can say that our VAB will be minus of 2 divided by 7 times V. And for magnitude, we get VAB is equal to 2 by 7 times V. And the option that is given to us, it tells us that the speed is given as 2v by 5. So this statement is false. So you can say statement C is false. Statement C is false. So the entire question was based only on the, we can say, the conservation of momentum. This completes the question. Thank you.